This video will cover problem solving in chemistry, which we're looking at chapter 1.4. I should note that we are going to be doing the math for the problems in class, so we are not going to be taking the time to do the math on any board here. Rather, that is going to be done in class. This will focus more on how to solve the problems, identifying the 3 steps in solving numeric problems, and being able to list the knowns and unknowns in a problem. Clearly, that last objective, list knowns and unknowns in a problem, if I give you a problem on the exam, you may be just asked to list what you know and what you do not know but will need to know. Take, for example, going to the supermarket. One problem we may run into when shopping is trying to purchase the cheapest cereal, but something still that we want to eat, obviously. So we need to develop a plan. How are we going to use that plan? Well, let's say we look at the cost, and we're going to take the costs and look at the amount of food that we get for that cost, so we can come up with a cost per unit. So how many grams of cereal do we get per dollar? That would be a way we could approach it to find out what is the cheapest cereal. This is approaching a problem using problem solving techniques. So the 3 techniques we will be using are analyze, calculate, and evaluate. So first off, analyze. Determine where we are starting from. So what are the knowns? And what are we going to be calculating? And also analyzing is kind of coming up with a plan. How do we get from our knowns to our calculations? You're going to find out pretty often that part of the analysis is figuring out what conversion factors are we going to use, or what equations are we going to use. So here we have a problem. The white-throated needletail, it's the fastest bird in level flight, so not like stooping like a falcon, can move at 47 meters per second. How fast is this in miles per hour? Okay, what's known is that the speed is 47 meters per second. What are we going to calculate? How fast it is in miles per hour. So how do we get from the known to the calculated? Okay, we have to get away from meters to miles and seconds to hours. So we're going to need some conversion factors for that. So the calculating step is using these conversion factors. So let's first get meters into kilometers, because kilometers are a little closer to the miles per hour. So let's see, it's going to be 45 meters per second times 1 kilometer is 1,000 meters. You're going to notice those cancel out, the meters cancel out to get kilometers per second. And you're going to multiply this by 3,600 seconds per hour. And that's going to give you kilometers per hour because the seconds cancel out. So now we have kilometers per hour. They will multiply that by miles per kilometer. So 1 mile is 1.609 kilometers. And the kilometers will then cancel out, and that will give us miles per hour. So 47 meters per second will be 105 miles per hour. And that's your calculation. The next step is going to be evaluating. Is this a reasonable answer? So it's the fastest bird in level flight. So, okay, it should be a high number. But if we had 1,000 miles per hour, well, that bird is probably going to combust due to friction with the air. So that would be too fast. If we ended up with 10.5 miles per hour, well, that's not really a very fast bird at all. I swear I've seen hummingbirds move faster than that. So that would not be a reasonable answer. So we want to make sure that the answer sounds reasonable. I had students once calculate the girth of a tree. So how wide is a tree? And students were coming up with 16 meters. Okay, 16 meters, let's see, how many feet would that be? That's roughly 48 feet wide. That's not a reasonable girth of a tree. We don't know trees that are 16 meters wide, and that's a stop and evaluate example. Also, is it in the correct units? So we wanted miles per hour, we ended with miles per hour. Good, check, that is the correct units. How long does your hair grow in a 50-minute class? You're given the fact that hair grows at 1.5 centimeters per month, and that there are 30 days in a month. We're just taking a normal 30-day month. So what's our analysis? Well, what do we know already? Well, we know how fast your hair grows in terms of months, and we know that months are certain days. So what we can also know is how many how long a class is. A class is about 50 minutes. So we can start calculating from here to say 1.5 centimeters per month. 1 month is 30 days, so the months cancel out. 1 day is 24 hours, so you had the days cancel out there, and you end up with centimeters per hour. Then you find out that 1 hour is 60 minutes. The hours cancel out, and you'll get you get centimeters per minute. Then you multiply by 50 minutes for one class, and the minutes cancel out, and you'll end up with how many centimeters per class. You notice that this is in scientific notation, which is something we will cover later. Here's a sample problem we're going to be doing in class. This is sample problem 1.1 from your textbook. And what you can do here is you can analyze, you find out what are the things we know. Well, we know how many blocks something is. We know how many miles someone can walk in a given amount of minutes, and we know how many blocks equal a mile. What are we trying to calculate? We're trying to calculate how long something will take. So we're going to calculate those out. And we're going to do that in class. Then we're going to evaluate, does that sound reasonable? Like, is it going to take us 13 weeks to move 8 blocks or something like that? That's clearly not a reasonable answer. Now let's look about non-numeric problems. Obviously, we're just going to take the calculate thing out of there. We're just going to analyze it and solve it. So that's going to be something like making a diagram, for example. That's an analysis. What do we need to know? Where are we going to end up? And then we just go and we just solve it. So make a plan for how to solve it. And of course, test to see if the solution adequately addresses the problem. These will be diagrams, flowcharts, and models. Obviously, there is a time and place where a model is not going to be appropriate or a diagram is not going to be the right answer.